Hello and welcome to everyone in physicsfire. Today we are going to do the second part of motion in a straight line. Yet we covered about distance, displacement, and even motion also. What is motion, right? And then we covered about the instantaneous speed, average speed. So today's class we will see related numericals what we had done yet, and then we are going to see motion under gravity, few numericals related to that motion under gravity. So let's start with the formulas like whatever we did yet, kind of revision whatever we had done. So first, if you'll see, we had done distance. Distance is what? Total path length covered by an object, right? Displacement is what? Shortest distance between initial point and final point. Then if you'll see, we had done speed. Speed is equal to what? Distance by time. Okay, distance by time, right? Then we had done displacement, velocity. Velocity is what? Displacement by time. Then we had done acceleration, right? Acceleration is what? Change in velocity. Change in velocity by time means final velocity minus of initial velocity by time. Achha, unit is what? Meter per second. Meter per second here is what? Meter per second square, right? Scalar quantity, vector quantity, vector quantity, right? Instantaneous also we had done, so we can say dx by dt. This is what? ds by dt, and this is what? Differentiation of velocity will give you what? Acceleration. So this is acceleration. Fine, till here we had done. Let's start today's class like whatever we want to do in today's class. The first numerical says that what? Given s is equal to t cube minus of 60 square, find the acceleration when the object is at what? Rest. When the object is at rest. Fine. So for finding the object is at rest, we'll have to do what here first? Anyway, we'll have to find acceleration, right? Acceleration is we'll have to find acceleration, but we'll have to find first velocity because displacement is given. So from displacement, if you want to find acceleration, then what you should do? First you should find velocity, ds by dt. Then we can differentiate one more time, we'll get what? Acceleration. Fine. So we can say ds by dt will give you what? Velocity. Let's do this first. So now we can say 3t cube, right? X to the power 3. So we can say 3t square minus of 12t. That we got velocity. Now think, if you will differentiate one more time, we'll get what? Acceleration, right? Now it is going to be 6t minus of 12, right? 60 minus of 12. So they are saying anyway is what? When the velocity is object is at what? Rest. But they are saying that what? Object is at rest. If object is at rest, then v is equal to what, guys? 0. So 3t square minus of 12t is equal to what? 0. So if you will take common here, here it will come 4, and then t square and t will get cancelled out. So t is equal to how much? Plus minus 4 actually you will get, right? What you will get? Okay, let's solve it properly. If you will not get by this way, we can take by this way. 3t square minus of 12t is equal to 0. So 3t, so this t minus of 4 is equal to 0. 3t is equal to 0, and second is what? T is equal to what? 4. So here t is equal to 0 and t is equal to what? 4. Let's take acceleration is equal to, anyway we got this thing, right? Now put t at t is equal to 0. At t is equal to 0, we can say it is acceleration is going to be what? Minus of 12 meter per second square, right? Why 12? Here if you will put t is equal to 0. At t is equal to 4, if you will see, then this is going to be 24 minus of 12. 12 only, right? Plus of 12. So acceleration is going to be plus of 12. That's it, right? So these two accelerations are there, we can find when the object is at what, rest, minus 12 and plus 12. Now the next question, with vectors, we had done already vectors, right? Displacement is given 40 I cap plus 60 j cap. Find velocity at 2 second and acceleration at 2 second, speed at 2 second. Guys, for finding velocity we'll have to differentiate one time, right? So let's find this. Now we can say, what is that, velocity first. Let's do, so ds by dt, that is going to be the velocity. So 4 I cap, right, only t is there, no, and 6 j cap, that is the velocity. That's it. At 2 second they are saying, better if you'll take something square, that is going to be okay, fine, anyway we will not use anything. So velocity is how much here, in x-axis and y-axis we found. So we can say velocity is going to be what, 3t I 4 I cap plus what, 6 j cap, right? Now if you will see, speed is what, mod of v, right? Velocity vector mod of v means what, guys? 4 square plus what, 6 square, root under of that. So it is going to be what, 16 plus what, 36, whatever it comes, 12 and 52, root 52 meter per second, that is going to be the speed, right? But the problem here is what, it does not depend upon time, right? If it does not depend upon time, then we can say no, directly, that acceleration is going to be 0, because velocity is constant, right? Velocity is constant. Velocity is what, constant. If velocity is constant, then we can say acceleration is what, 0. That's it. Hope so you guys got it, right? Next, if you will see direction of motion. Direction of motion explained by velocity of motion, right? Not by displacement. Suppose displacement is like, whenever we will see, like, displacement will not give you the direction of motion. It is only explained by what, velocity. Let's see, we'll see those questions also. Solution of this question, if you will see, one question is given, s is equal to t cube minus of 60 square plus of 90. Find the velocity at 2 seconds, right? So let's see, there we know velocity, we will get ds by dt. So that is going to be 3t square minus of 12t plus of 9, right? Now time, if you will put 2 here, that is going to be 4 minus of 24, right? 24 plus of 9. So 12 minus of 24 is how much? Plus minus of 12, minus of 12 plus 9. So minus of 3 meter per second. Now see, minus of 3 means backward direction, right? Now acceleration, guys, acceleration is equal to what, dv by dt, right? dv by dt means acceleration, differentiation of this. So we can say 6t minus of what, 12 plus of what, 0, right? So this if you will do, then now put time value, time is 3, so if you will put time here 3, then 18 minus of 12, it is going to be 6 meter per second square. That's it, right? So direction of motion, remember the direction of motion will be given by what, velocity, not by displacement. That is important point. Fine. Now what, derivation of equation of motion. We have three equations, v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. These three equations we should derive. If you want to derive these three equations, many ways are there, but we'll do directly. Now we are supposed to do by integral method, right? Graph and all we will not do now, because that is in class 9. So we'll do by derivation method, like integral method, right? Equations of motion. Actually, it is under gravity, that is also we should consider. One more thing here, the biggest problem for this equations of motion that we should know is, acceleration is constant. Acceleration is what, constant. Then only we can use this equations. Means three equations, v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. These three equations of motion we will use only in one time, like at one condition when acceleration is what? Constant. If acceleration is not constant, we cannot use these equations, right? So that we should keep in mind. Let's start now the derivations. Guys, here if you will see, three things are there. Now I'll tell you one rule. It is really easy if you will do by this way. What are the things are there? Now you take the starting things. V, let's start from S, right? And then we'll go with V and then acceleration. Guys, whenever displacement is given, no, then you should do differentiation of that, right? Displacement is what? ds by dt. Velocity is what? How you will do now? Velocity, one step you go forward, so dv by dt. Acceleration means you should differentiate what? You should differentiate this, you should differentiate this, you should differentiate this, then only you will get the answers, right? What I'm saying, suppose displacement is you want to find, then differentiate that. Velocity you want to find, differentiate that. Means ultimately you write acceleration. That is what I'm saying, you write. It means you go one step ahead, you go velocity. Velocity is what? ds by dt. Velocity if you want to find, then you should do what? dv by dt. Means acceleration you are finding. That's it. If you'll do by that way, it will be really easy. Let's see now like how to start. That I told you how to start. You go one step ahead, differentiate that. You go one step ahead, differentiate that, right? Go one step ahead and differentiate that, so that what you will get here is you will get the like where to start. Generally student gets confused like from where to start to deriving this. So that is the way. Fine. Now we can say, guys, first we want to prove this one, right? V is equal to u plus at. So what I told you, one step ahead, so dv by dt, right, is equal to what? Acceleration, right? dv by dt is equal to what? Now we can say dv is equal to a dt. Okay. Now integration by integral method. Achha, from where to where? Velocity obviously will change from initial velocity to final velocity. Initial velocity, how we represent? U. Final velocity we represent by V. Actually, acceleration is constant. Whenever acceleration is there and that is constant, that will come out. It is in multiplication, right? So acceleration will not differentiate, will differentiate time. So 0 to t. Now, whenever if you don't know integration anything, even though you can integrate this one, what you can do is whenever d and integration symbol is nearby, you can cancel it out. Or dv integration that we learned in maths, like two topic basic maths, there you can see, you guys can watch that, right? So here directly we can write as what? V, dv integration is v, u to what? V, and then what? A t. Achha, from where to where? Anyway 0 to t. Now first you will put final what is that? Upper limit, right? And then lower limit. This is what? Upper limit, this is what? Lower limit. So we can say v minus of u is equal to, anyway if you will put t here, 0 0, so at. Guys, v is equal to u plus at. The first equation we got. Easy, right? If you don't know anything in integration, what you should do is d and integration is nearby, cancel it out. That's it. V is equal to what? U plus at. Fine. Now the next s is equal to ut plus half at square. As I told you before also, what you should do is you go to one step ahead. So ds by dt, right? ds by dt is equal to what? Velocity. So ds is equal to let's write little this side, otherwise space problem will be there. ds by dt is equal to velocity. Now ds is equal to v dt. V is equal to what, guys? V is equal to u plus at. From the first equation, V is equal to what? U plus at. U plus at into what? dt, right? Now integrate this again. If you integrate this, then from where to where? 0 to what? S, right? How much it will go up? That is what. Now here again what? 0 to what? T. Okay. So ds integration is what? Again S only. Anyway, u dt plus what? A t dt. Yes. Achha, from where to where? 0 to t. U is constant anyway here, that will come out. So dt integration is directly we can say u into what? T only, right? T into dt. X dt integration is what? X square by 2. So t dt integration is what? T square by 2. So we can say t square by 2. Acceleration will come out. 0 to what? 2. So we can say ut plus half at square. Array, we got another one. S is equal to what? Ut plus half at square, right? So that also we got. Let's see the next one. V square is equal to u square plus 2as. Again v, right? We know, then we should go what? Again differentiate that, right? Dv by dt is equal to what? Acceleration, right? Dv by dt is equal to acceleration. Guys, here what we can do now, you just do ds by dt, ds by ds, and dv by dt is equal to what? Acceleration. Okay, now ds by dt, see, we are writing acceleration in a different way. We can multiply and divide, right? There is no problem at all. So now we can do what here? Ds by dt is what? Is velocity. Dv by ds is what? Is equal nothing, right? So v dv, acceleration we can write v dv by ds also. V dv by ds. So we can say now, I'm writing with little v dv and ds a ds. That's it. 0 to what? U to v, not 0 to v. Initial velocity to final velocity, and 0 to s. Anyway, x dx integration is what? X square by 2. So v dv integration is what? T square by 2. As we had done, t dt integration is t square by 2. So v dv integration is what? V square by 2, right? So v square by 2 upper limit is u v, right? Ads is what? A s only. Then v square, let's write it, v square by 2 minus of u square by 2 is equal to as. So v square minus of u square is equal to, let's take 2 that side, so 2as, right? So v square is equal to 2as plus of u square. V square is equal to u square plus 2as. 3 equations finished. Hope so you guys got it, right? So we can use these equations whenever acceleration is constant. If not, you cannot use. Remember that. Easy only, right? Now we are going to see motion under gravity. Motion under gravity means, suppose this object is there, if it is falling. Now this object is there, if it will fall. Now see, it will fall, right? This is falling due to what? Motion under gravity only. So these types of motion, if you analyze, like just before hitting the ground, what is the velocity? Just before hitting the ground, what was the acceleration? Anyway, is constant only. What is, how much height it covered if you'll throw an object, right? Those types of question we are going to cover in this. Here sign convention is important, guys. Now remember, suppose this is the reference line, right? Reference lines above, if you are going above of reference lines, then anything like displacement, velocity, acceleration is going to be positive. If anything which is coming below the reference line, then it is negative. That's it. That is important, really important. Let's see what I want to say you here is, suppose this is the reference line. If this is the reference line, and then you are going above of this, and then you are coming below of this. Wait, I'll take yes, exactly. Now if you are going above means, suppose the like above the reference line, right? Above the reference line, if you will see, we can say that what height, if you are going up, you are taking up, then positive. U if you are taking up, then positive. V if you are taking up, then positive. Acceleration due to gravity is always negative, because it is always downward direction. Always what? Downward direction. If it is coming down, H will be what? Negative. U will be what? Negative. V will be what? Negative. That's it. Hope so you guys understood. If the object is going above the reference line, then positive. Below the reference line, then negative, right? Suppose if you are going in a tower and then throwing on object, right? So height is what? Below. So that height will be what? Negative only. Fine. Let's see if you numericals, from that you understand in a better way. Now a body is thrown vertically upward with a speed u. Find the time taken by it to reach. Find the time taken by it to reach the, what is that? A body is thrown vertically upward with a speed u. Find the time taken by it to reach the maximum height. Guys, at maximum height we can say, suppose from here if you are throwing, then at maximum height here, then v is equal to going to be what? 0. U you want to find, right? If you are throwing u, right? Acceleration we know that is what? Minus of g. Now you have v, now you have a, now you want to find u, and then they are saying find the time taken by it. So we can say what equation? V is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. We don't have that much of things, so v, u, t you want to find, these all things are given, that's it. Find the speed is u anyway, so we can say we can use v is equal to u plus a t, right? If you use this equation, v is what here? 0. U is what here? U is u minus of what? Gt. So gt is equal to what? U. T is equal to what? U by g. Correct? T is equal to what? U by g. Next, let's see. Next, if you will see, what is that? Maximum height. Now think how we'll find maximum height. Maximum height, how we'll find? U by g, maximum height. Now maximum height if you want to find, then we can say, now we have time also. V square is equal, this we can use, no, v square is equal to u square plus 2gs. Achha, g, okay, let's, v square is anyway 0, u is u square only, minus of what? 2gs. 2gs, s is how much here? S we want to find, right? So 2gs is equal to what? U square. S is equal to u square by 2g. That's it. S is equal to what? U square by 2g. Time taken to reach the initial speed. Time taken to reach the initial speed, right? Now how you will find? Think little and then we can find. Yes, the third question is what? Time taken to reach the initial. Ultimately from here to here, right? From here to here, and then what? From here to here. So 2t, right? T is equal to ultimately capital T, let's write, total time taken is equal to what? 2 small t. So 2u by g is the total time taken, right? Hope so you guys understood this. Now see this question. A stone is dropped from a tower of height 20 meter. Find the time taken to reach the ground, speed just before hitting the ground. Think little. 1-2 minutes. You guys try by yourself, then we'll see. What is that? A stone is dropped from a tower of height 20 meter. Find the time taken to reach the ground. Right? First is time taken to reach the ground, speed just before hitting the ground. Think little. Acha, when you will drop, u is 0. See, 2-3 things you should understand. Whenever, like, it will not be given directly in numerical. When you will throw anything, right, it will go to the maximum height. So at maximum height it will come and then it will return back. It means at maximum height, the final velocity of the object is going to be 0, right? Acha, acceleration due to gravity a is always negative. And then what? If you throw it upward, then initial velocity is required. But if you will drop it, then u is what? Generally 0 only, right? Till the time you are not doing like this, right? Fine. Speed just before hitting the ground. So that also we'll have to find, like final velocity kind of. Fine. Let's try this question. So the tower, if you will draw, let's take, this is the tower, right? A stone is dropped from a tower of height 20 meter, right? And then what is that? U is here what? 0. U is what here? 0. Obviously acceleration is how much here? Minus of g, right? We want to find first is what? S is given here as S is what? Now think from the reference height, this is the reference height coming down, so S is what here? Negative. S is what here? How I wrote, let me write it again please. U is what? How, see this equal to how I'm writing? U is, why it is happening? U is 0. S is what here? minus of 20. S is minus of 20. A is minus of G, right? Anything else? Nothing. Now find time. So what equation we will use? S is equal to ut plus half at square, right? S is equal to, what is, S is equal to ut plus half at square. S u is 0, so 0 plus half minus of 10 into what? T square. Achha, S is given minus of 20. Wait, I'll write with A from next question. Minus of 5 into T square. So that is going to be 4 minus minus plus. So T is going to be what? 2 seconds. That's it. Now just time speed just before hitting the ground. Speed just before hitting the ground. If it will hit the ground, then what will happen? Final velocity. Okay, we want to find. Now we have anyway time, right? That is 2 seconds. U we have 0. A we have minus of G, right? A we have what? Minus of G, and then yeah, that's it. I don't think so. V is equal to U plus AT. V is what? We want to find. U is what here? 0 minus of what? 10 into what? T. So V is equal to minus of 20. Achha, one more thing you can see. Because it is downward velocity, right? That's why minus. Just showing. Hope so you guys got it. Let's see the next question. Next question is what here? A ball is projected vertically upward from a tower of height 20 meter at a speed of 5 meter per second. Find maximum height reached by ball, time when it passes from its mean position. A ball is projected vertically upward from a tower of a height of 20 meter at a speed of 5 meter per second. So what is U here, guys? 5 meter per second, right? 5 meter per second. And then what? Height is how much here? 20 meter, right? And then what? A is what here? Minus of G. What they're asking first? Time to, what is the find the maximum height reached by the ball. Find the maximum height reached by the ball. So we can say no now. How S we want to find, right? S if you want to find. And one more thing we can say no here. What is that? Final velocity is going to be 0 at maximum height. S is equal to Sy will take. We don't have time, so let's try with directly. What? V square is equal to U square plus 2as. V square is what here? 0. U square is what here? U square we 5, so 25 plus what? 2 into minus of 10 into what? S we want to find. So we can say minus of 20, this side will become plus, is equal to what? 25, right? So now we can say here S is going to be 1.25 meter. Yeah. Now what? Now they're asking that what? Find the time, right? Time is V is equal to U plus 18. Time taken when it passes from its mean position, right? So V is equal to what? U plus AT. V is how much here, guys? V is 0. And then what? 5 minus of 10 into what? T. So it is going to be how much? 10T is equal to 5. Yes, time is equal to 0.5 meter per second, right? 0.2 also we can say. This also we had done. So till here you guys revise. Next class, no 1-2 numericals of this topic will start, and then we'll continue from there. Relative motion and all, relative motion in one dimension and all will continue. Till here you guys revise. We'll see in the next class.